Okay, problem 5 from the quiz asks you to explain how this IP address, it's a Class C IP address, it asks you to explain how it gets transmitted through the network and how it then gets stored in memory. The next one had to do with what does this assembly code mean. So looking at problem 5 first, we talked about the notion of big endian versus little endian. So big endian network data uses big endian. So in other words, if this is this IP address of 127.0.0.1 in hex, it is actually 7F, which refers to 127, and then 000001 refers to this is 0001 due to the fact that this is in hexadecimal, and hexadecimal is base 16, and IP addressing are represented in binary, which is base 2. So 7F would be 7, and you see you take this binary and then you divvy it up into I think I described them as chunks or nibbles. So if a byte is 8 bits, then a nibble is 4 bytes. It's a half of a byte. A nibble is, and the 4 bytes gives you the 16 possibilities. So if you divvy up the first group of zeros and ones and the second group of zeros and ones, the first group of zeros and ones will be 7, and the next one will be all ones, or F, 1 1 1 1. And so that's what gives you your 7F. And then, of course, 001 translates to in hex 0000 and 01, because the first 9 digits are exactly the same. Anyways, the hexadecimal translation of 127.0.0.1 is 7F0001. Okay, now it's sent into the network with a notion of big endian. So it's sent to the network with the most significant bits first, which means it's OX, referring to the fact that we are reading hexadecimal code, not binary. So OX, X is hexadecimal. And then we start with 7F, and then this is basically a copy and paste of this. You can envision it, because big endian sends the most critical bits first, and we all know that the first critical bits in an IP address is the first octet. So that's why it's sent over the network using big endian. Now, little endian is how it's stored. So it's stored in RAM with the most significant bits last. Okay, so that should explain how you can differentiate between the transmission of how the bits are transmitted versus how they are stored. They are transmitted using big endian, and they are stored using little endian. When it comes to assembly language, the assembly command move, like take the garden variety, if you will, of assembly language. This would be something like, here, let me just... The garden variety assembly language would be something like move EAX 004C. That says move the value of 004C into the EAX registry. Now, registries are used in compilers prefer, or CPUs prefer to use registries such as EAX because they're actually quicker than RAM, if you will. So what this assembly instruction says is move the actual value for C into registry EAX. Now, when you have the open and closed straight brackets, that does not refer to 004C. That refers to the memory location 004C, and that memory location is going to have a value inside of it, which would be, in this case, if you looked at the diagram on the quiz, is 4141. So what this is actually saying is that this instruction, move EAX location 004C, it's asking you not to move the literal 4C, it's asking you to move whatever is inside the memory location of 004C into EAX. So based on this diagram, that would be true. Okay, now if you have any more questions, feel free to make an appointment on the syllabus, and I'm also open on Friday. So if you're working Saturday and Sunday, I'm also available, like I said, on Friday. Thank you.